EG71 can collect data from devices across a whole range of protocols: LoRa, BACnet, Modbus, KNX, and I/O devices, each with different onboarding methods. Let's go through them one by one. If you already know which network your devices will use, you can configure it in advance under Device Access Network, so you can simply select it when adding devices later. The LoRaWAN network is pre-installed based on the gateway's frequency and cannot be deleted, though you can edit it if necessary. For other protocols, you'll need to create access networks manually. Be sure to configure the correct parameters for each type. For demonstration purposes, I've set up access networks for all protocols. In practice, you only need to configure what you actually use. Alternatively, you can skip this step entirely and configure the network while adding devices. The choice is yours. Let's start with adding LoRa devices and their objects. For Method 1, Manual Edition, here's what you do. Give your device a custom name, select LoRaWAN as the protocol type, and you'll see all the fields needed for LoRaWAN communication. Since Milesight LoRaWAN node models are already in the device library, just pick the right device model, fill in the device EUI, and the rest auto-populates based on the model's preset. Once you're done, click Next Step to move on to object selection. Now let's add objects. EG71 converts terminal device data into objects, which makes integration really straightforward. If you picked a device model in the previous step, all the forwardable objects for that model will show up here. Just check the ones you want. After that, you can always go to the device list, click Object Count, and manage your objects from there, enable, disable, or add new ones from the device library. But what if you're adding a completely new LoRa device from scratch? You can manually fill in all the info and move on, but you'll find that LoRaWAN devices don't allow custom objects. So you can just skip adding objects. Then when you set up data forwarding over MQTT or HTTP, you can add the entire device and leave the payload parsing to the upstream system. We'll show you how this works later in the data forwarding part. Method 2 is NFC Tap to Add, and this one's only for Milesight devices. Activate the EG71 and just bring the device's NFC area close to the EG71's NFC spot, and it enrolls automatically. If adding fails, the LED flashes twice. If successful, green light stays on for 3 seconds. Back in the device list, the system will match the device model from the library with the device's information, payload codec, and objects. You can also edit the device information if necessary. Please note that the device model of WS501/502/503 can't match automatically and needs manually selection on edit column. For objects, go to Object Count in the device list and manage them there. And again, LoRaWAN devices don't support custom objects. Method 3 is LoRa Device Scan and Add. This is the one we'd recommend for batch onboarding. Navigate to Scan to Add and choose Scan LoRaWAN. Configure the app key for device scanning. For Milesight devices, you can use the default Milesight key. For custom keys, you can either import a CSV list, usually provided by the manufacturer with the order, but before importing, be sure to review the file requirements, format, size, header, etc., covered in the video to ensure a successful import. Or add them manually. Both methods work for Milesight and third-party LoRaWAN devices. Click Start Scan to search for LoRa devices that match the configured app keys and gateway frequency. The scan continues even if you leave the page. You can return at any time by clicking LoRaWAN Scanning in the upper right corner of any page. When new devices are detected, the device count label turns red and turns gray after checking. You can add desired devices directly to the system. If a device has multiple model options, we recommend selecting the correct one before adding. Otherwise, the model will default to none in the device list. In that case, you can still manually edit it later. Unneeded devices can be ignored. You can also unignore them later to restore them to the list. Clicking Abandon Scan stops the current scan and clears all unadded scan devices. Next up, let's add BACnet devices and objects. For BACnet, Manual Edition works like this: name your device, pick the BACnet MS/TP as the protocol type, and fill in the details. If you've already set up a BACnet device model in the device library, just select it and the parameters will auto-populate, including objects. Now, unlike LoRa, BACnet requires you to set a device access network so you can collect data from endpoint devices. You can pick the right one and check if you have already set it up earlier under Data Acquisition, Device Access Network. You can do this right here while adding the device. For objects, if you chose a device model, all the forwardable objects will show up. Just check what you need. You can also manage them later through the object list. You can pick from the device library or add custom objects manually. And here's a nice feature: if your BACnet devices are on the same local network, you can also add objects by scanning. I will show on the next example. Method 2 BACnet supports adding objects via scanning too. Go to Scan Edition. Create an access network for your BACnet device, or select an existing one if you have already configured it. We suggest setting a smaller device instance NR range as needed to speed up scanning. Then click Next Step to start scanning for BACnet devices. Once a device is detected, stop the scan and proceed to the next step for Object Edition. Select the desired device, and scan for its supported objects, which will be displayed on the right column. You can select the ones you need immediately. After addition, you can manage objects later via the object list, either manually add new object, or by scanning for additional unadded objects. Now let's look at Modbus devices. For Modbus, Manual Edition is the only option. Name your device, choose Modbus TCP, Modbus RTU, or Modbus RTU over TCP as the protocol type. The required fill-in content is a little bit different. Here we add an Modbus TCP device as an example, filling in the required information based on your device and connection. For Modbus device, you also need to set up a device access network to collect data. You can do it right here or select the Preconfigure one in the Device Access Network module. Similar to before, if you have preconfigured a Modbus model in the device library, simply select it to autofill the parameters and directly pick its objects and confirm. Click Previous if no model is available or the existing one doesn't match. Select None for device model. There will be no objects for selection, but you can customize the objects later in the object list. After addition, you can edit the device from the device list page and manage its objects via the object list, whether you need to edit read present values, enable, disable, or add new objects. Now let's edit the device and to show you what you can do if you have select an device model. Go to the objects list. You can add objects associated with this device model from the device library, or custom new objects for the device. Then you will be able to edit, read present values, enable, disable the objects. Next, add KNX/TP devices. KNX/TP also only supports Manual Edition. Name your device, select KNX/TP as the protocol type. Since there is only one KNX interface, the device access network will be automatically enabled if you have preconfigured it in the Device Access Network module. Otherwise, you will be prompted to create one. Similar to before, if you have a preconfigured KNX device model in the device library, simply select it and enter the device's physical address. Then click Next Step to select Objects. The group address is required. It tells the gateway which KNX channel to read from or write to. Click Previous if no model is available or the existing one doesn't match. Select None for device model. In this case, no objects will be pre-selected, but you can always customize them later in the object list. You can add an custom object by filling in required parameters, and edit, read present values, enable, disable this object. Now let's edit the device and to show you what you can do if you have select an device model. Go to the Objects list. You can add objects associated with this device model from the device library. Then you will be able to edit, read present values, enable, disable the objects, or custom new objects for the device. The KNX device is added successfully. Finally, add I/O devices. Head over to Data Acquisition, then I/O device. Here you can enable the I/O interface types that match your actual deployment and adjust the parameters. Except for the above methods, Batch import function allows you to import device list file to add devices in batch. You can choose between .xlsx and CSV files, but the upload rules differ slightly depending on the format. You can either download the template file to fill in device information, or export the device list from the gateway and modify it before importing back. For XLSX files, devices of different protocol types can be included in a single file, organized by separate sheets, so only one file needs to be uploaded. Now let's delete just added devices and upload again in CSV file type for demo. 4 CSV files. Separate files must be uploaded for each protocol type. So this is how to add devices via batch import.